Hello and welcome back to Matrix Decoded. I haven't posted in a very long time, in particular 3 months ago, and the reason was because I was extremely busy with a lot of schoolwork and applications for high school and specific regional programs, which we had to perfect the test for in order to get in. So I ended up getting into my choice program, and that's why I wasn't able to post for that long, 3 months. The last time I posted was 3 months ago, Dictionaries, Part 8, following up on the project of Dictionaries Part 7 and 6. Today I will be posting a video on the turtle module, which specifies in drawing in the turtle Python. Literally speaking, turtle really isn't an animal in Python, just like Python isn't an animal in the coding-based platform Python. Python is for coding. It's like a coding platform. Therefore, turtle originates like an animal, and turtle in Python is used to draw. Specifically asking, you may be wondering, well, what can you draw? You can draw literally anything. You can print text on it, you can make a game on it, which will come in future videos. You can really do anything you want on the Turtle module. That's what makes it so interesting. Anyways, enough talking, let's get right into Turtle. So over here, I have opened a new file in the latest version in this making of the video of Idle. And I have opened a new file, and in our folder from previous videos, this is where we save all of our files. And let's go ahead and save this as first turtle program. Let's begin with importing the module. And there are many modules in Python, varying from time to random, and random we have used in previous videos, and it goes something like this: import random. So we're importing the module random, which in other cases is like a predefined or built function. So today we're going to be doing import turtle. And after we have imported turtle, we're going to assign a letter, a variable, correlating to turtle. Similar, if not like this. T is equal to turtle dot capital T, and the capital T is essential, otherwise the rest of your program won't work because you haven't really called turtle into this module. And then brackets open and brackets closed. And right now what we did here is that we've told the computer to recognize that we are using the turtle module. So let's go ahead and see what happens when we press run. So let's save what you have so far and run it. So let me just drag my canvas over here, which is here, and we've got a blank canvas. And there's nothing really here other than Python Turtle graphics on the top here, which is really not that important, and a small little feather sign, which I think is actually an ink pen, and we have a small little green arrow here, a small little black arrow here in the middle of our canvas. Now this isn't really doing anything, and the reason being is because we haven't told the small little black arrow to move or do anything yet. And we need to give those commands, such as turtle.move forward or turtle.move left. By inputting specific commands, we can bring our turtle little arrow to life. So let's go ahead and do something with our code. And I have closed our canvas so it's easier for us to concentrate. Now, if we actually want our small little arrow to move, we have to give it commands as I previously mentioned. So we're going to do t.forward. And let me make myself clear. We're not going to be writing turtle because, as I said earlier, we assigned turtle a variable so that it's easier for you or any coder to write turtle much faster. And actually we can assign this anything and it will function. So we can do SW, it's just a random two letters that I put together, and SW forward. So SW is essentially the arrow, and the arrow is assigned any random letter that we assign it. So I'm just going to do T because it's the most easiest, most common, and most effective. And I'm just going to put T back here. And T.forward, that's we're indicating that we want to move forward. And this is a 2D based platform, which means that we can't have 3 dimensions. So we can only have the x dimension and the y dimension. The z dimension is the dimension which goes back and forth, just like in physics. So in this, we're only going to have 2 dimensions, and we're going to have t dot forward, brackets, open and close, and inside we're going to input this number 50. 50 is a very important number because on our screen we have something called pixels. Now you might not notice, but if you look really hard and really close into your computer, which you shouldn't because it can damage your eyes, but just for once you could, and you would see really, really, really small squares. And these small squares is what makes up our screen and what we're able to see, like the graphics. So by putting 50, we have just said, okay, move 50 pixels forward, which is going forward in the x dimension, because x is horizontal while the y dimension is vertical. So let's go ahead and see what this code does. So once we run it, I'm just going to drag my canvas over, and once we run it, we see that we have moved 50 pixels forward. Now, I don't recommend counting because that would be incredibly hard, but it's pretty reasonable estimate to move 50 pixels from the beginning of this line to the ending of this arrow. So congratulations, you just made your very first turtle line code. Now that you've created your first line of code in Turtle, I would like you to know, or I would like to inform you about angles in Turtle, which is extremely annoying, well, in particular for me, but it's also really important for you to know how these work. So I'm gonna put t.left, and t.left is moving left, and inside we're gonna import a number, and this number can vary from 0 to 360 because that's how much degrees there are in a circle, and which is essentially all of the angles. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way to 360. I hope I made myself clear on that. Now if we input a number such as 60, let's say, and we run it, and I'm gonna drag my canvas over, and then we want to move forward. So we've moved 60 degrees. Okay, so that looks pretty good. Now let's go forward. And we're gonna go forward maybe, let's say, 100 pixels this time. So let me drag my canvas over, and it says we've moved 60 degrees. But really, when you look between these two segments, that looks well over 90 degrees. And maybe looking like a triangle if you put another line segment here and here. And that really doesn't look like 60 degrees to me between these two line segments. It looks well over 90. Maybe we could say 130. So the reason why this isn't exactly 60 degrees is because imagine if this line right here, the one that's going on horizontal on the x-axis, was continuing far past this line segment over here. If you imagine that, then this line segment and that line segment over here, that would be 60 degrees. So it's basically like a mirrored reflection of itself. I particularly think it's fascinating, but at the same time extremely annoying. Okay, so now that you know the really basic of Turtle, we're going to create a small little program, and in this program we're going to incorporate the while loop. And the while loop, we've used it before in I think one other project which we did. So let me just open that back up, and we're going to be erasing all this code from on top. It's just a couple lines of code, so it doesn't matter. And we're going to make variables. Now we're going to say a is equal to, let's say, 2, and b is equal to 3. Now remember, 2 and 3 are integers, which means that we don't have to put quotation marks around these integers. And like we are assigning variables, a string can also assign to an integer. So a is equal to 2 and b is equal to 3. Now we're going to make a while loop. And if you're not familiar with while loops, they're really easy to understand. So everything that's in here is going to repeat, essentially. And it's already indented the code for us, which is fantastic. And we're going to say t.forward. And we're saying t again because we've on top of the while loop, we've said that t is equal to turtle. So forward, and we're going to say brackets close, brackets open, and we're inside the brackets we're gonna have A. Now I already know what you're probably thinking. You're moving forward of 2 pixels, which you are correct. And now we're gonna put t dot right, and we're gonna put in here B. Now we're gonna put A is plus equal to 1, and B is plus equal to 3. So over here, let me explain what we're doing. It's a really random piece of code, but I want to show you because of Turtle graphics and while loops are also important in Turtle graphics and why they can make such interesting results. So t dot forward, we just move this much forward, 2 pixels, right? And then we set t dot forward B, and then we move right, and then we go 3 pixels to the right. And then we say +1 and +3 for each of these things, and that's super cool. So now if we run this, I'm just gonna bring my canvas over, and we've got a program which is running right now. And it's never ending because it's in a while loop, which I told you, it essentially never ends. And right now we've got this small little bacteria cell, and let's see what it continues on into. So it's continuing on making triangle shapes, but then it keeps on expanding and expanding. And now it's going into some sort of like parallelogram or a quadrilateral with 4 shapes. And it keeps on expanding like such as exponential growth. Now this will keep on going forward and forward and forward, never ending. Just keep on going bigger. Right now it looks like one of the spinach rolls. So I'm gonna end this program right here, and you've got to see what it does. All this code here, it's really just unimportant. It doesn't really matter. Now that we've familiarized ourselves with the basics of Turtle, we're going to be doing a really fascinating challenge. So I'm going to remove this code, and due to the pandemic, I thought of making a challenge which relates to it. So we're going to make a bacteria cell using Turtle. And we have to use a while loop to speed the process. There are going to be some lines which I haven't taught you, but can be taught using, or well, you can use using your own judgment. So you can search up what Turtle different things you can do, like forward, left. You can change the pen speed, and you can even change the pen color. For this challenge, I will be explaining step by step on what we're going to be doing. Okay, so let's go ahead and start. So we already have our Turtle screen, which is the canvas, and I'm gonna make another variable which is equal to Turtle dot screen. Now turtle.screen is basically like controlling what you can essentially do on the screen. Let's go s.bgcolor, bgcolor, not gb, bgcolor, and what this does is that it sets the background color, so background. So it's just like the initials of background if you make it a compound word, and inside the brackets you can have any color that you want. So we're going to put double quotation marks as usual, and I think with this project black would fit well as a good background. And then we're going to have t.pen color. So pen color makes your pen blue, black, white, any color that you prefer. So you can do blue right here. It would fit. Black and blue are really good colors for this project. Now, going back to our variables, we're going to do A is equal to 0 and B is equal to also 0. And then we're going to do t.speed, and we're going to put 0 inside this. Now you may be wondering, well, if you put a speed of 0, how's it even going to work? Well, putting 0 as a speed makes it go the fastest, because essentially after that you cannot go any faster. Then we're going to do t.pen up. Then we're going to do t.pen up, and we're going to put our brackets. It's important to put brackets for everything except variables, otherwise it wouldn't work. And brackets for only the Turtle module specifically. Then we're going to do t.goto, and then we're going to put 0 and 200. Now these two numbers are coordinates where we're saying, okay, small little arrow, go to these coordinates. So essentially go to these coordinates. And then we're going to put our pen back down. So here is something that I haven't taught you yet, but is really simple to understand as we go along. So you're putting your pen up, right? It's just like when you pick your pencil up. I don't have my camera on, but in later videos I can show you. Imagine that you're holding a pencil, and if you can find a pencil, that would be even better. Now pretend you're drawing, and then you take your pencil up, and in midair you hover it around your paper, and you go to a specific coordinate, if it's on a graph paper, or you can just eyeball it on a regular piece of paper, and you're going to any random position, and then you put your pen down. So it's just like over here in this code. You're picking your pen up, you're going in midair, and then you settle on a specific coordinate, whether it's graph paper or plain paper, and then you put your pen down. And we're going to put our brackets. After this, we're going to do while true, because everything that we're doing is true. There's no reason for it to be false. And we're going to be doing t dot forward. Make sure you spell everything correct. And inside, we're going to put the brackets, the variable a. After that, we're going to do t dot right, and we're going to put the brackets, and inside the brackets, we're going to put our other variable b. And then we're going to do a plus 2 is equal to 2. Then we're going to do b plus equal, and no space, is equal to 0.5. Then we're going to do if b. So right now we're incorporating our if statements, which was, I think, the third video. If b is equal to 210, then break. And then we're going to say t dot hide turtle. So, and then at the end, we're going to do turtle dot done. Okay, so let's go over all this code. So we have import turtle, which is importing the module. Then we have t assigning as a variable turtle, turtle, and then we have our screen, turtle, s is equal to turtle.screen. And again, all these variables are just easier for us to do, or for any coder. And then we have s.background color, bg, and we set it as black. Then our pen color, which is blue, and then we have our variables a and b, which are both equivalent to the number 0, or the integer 0. And then we have our pen speed, which is 0, and we identified that this is the fastest possible speed to go. Then we took the idea or theory of pen up, and then we go to our coordinates and we put our pen down. Then we made a while loop, which never ends, and we said t dot forward a, which means that our variable 0 goes forward 2, and then b turns right on 0.5 degrees. And then if b reaches 210, break and hide the turtle. And then we say turtle dot done. So let's go ahead and run this. And we have to save our program. And let's see it running over here. So this looks pretty cool already. And you can notice how much more faster the code is running, because the speed is fast. Now this is sort of looking like a coronavirus cell, and it's blue, and blue and black fit really well together. So this looks like a really random coronavirus cell, which is super cool. And we made this using a while loop without actually having to repeat it. That would be monotonous and boring, extremely boring. So with a while loop and just a couple lines of code, we were able to make this. This is the end of our project, and I hope you really enjoyed it. It wasn't really a project, but a small little code to get you familiarized with what we created today. And we created a really cool coronavirus cell. And I actually went back and changed the color because I think coronavirus is green. So if I just drag it over here, this is the final project that we made today, and I hope that you enjoyed in the making of it.